You already started?
Yeah.
Okay, so this is the reaction A in part 2 performed by students. It is zinc element, gray metallic solid. Small quantity is in the beaker. The second reactant is blue solution of blue crystals, copper sulfate, aqueous. We are going to mix these two reactants together, and since I'm doing it in a beaker, I'm going to pour right from the bottle into the beaker. Small quantity of solution, and I'm going gently stir it. It's okay. I'm going to lift it maybe for the students to see better. The first observation we are going to make that the silver color metal became very dark brown.
Andrew, tell June to send it to me, the link, because you don't have speakers on there.
And the solution, the blue solution, is decolorizing. Almost no color. And if we give a little bit more time and maybe to add a little bit more zinc, then solution will be almost completely clear. I'm going to put a little bit more zinc. I'm trying to minimize use of spatulas and everything, not to put anything in the containers. And here, clear solution and brown metal. And what I'm observing when I'm holding it in my hand like that, or touching it from the bottom, that the bottom of the beaker and the sides of the beaker where solution is became very warm. And I'm trying to make better view for the students, since I never done it before, that the solution has no more blue color, and the metallic element at the bottom is dark brown. For you it might even show almost black. But if we filter our solution through the funnel and we collect the metal and dry it off, it will be lighter brown, reddish brown. So these were your original reactants, original substances which we put together, metallic zinc, an element, and compound in solution. And here is the result, which is colorless solution and different color metal, and this reaction was accompanied by change in energy. It was warm. So here would be what you can answer as the question about endothermic or exothermic, or neither, and you will have to fill in the products. Brown metal and colorless solution. That is reaction A, which I'm putting aside, and we are moving to reaction B. These two reactions, A and B, are from the same class of reactions in terms of change in matter. They are called single replacement reactions. And in terms of energy, they will be the same too, but that would be your conclusion based on my observation that it's warm. So I think I have to move it a little bit. No, on the contrary. Oh, here. That's, otherwise I'm showing on the side. This is, again, reaction between metallic element, but it is not zinc, it is magnesium. The same color as zinc. That shows better here. These are silver color metallic element, and I put one piece of this, a ribbon of magnesium, at the bottom of the test tube already. That's my first reactant. The second reactant is hydrochloric acid, which is stomach acid. Hydrogen chloride gas dissolved in water. That's what we have in our stomach. And probably about the same concentration as it was prepared by the stockroom. Metallic magnesium would never dissolve in water, but it appears that it might dissolve in solution of an acid. What we are observing here, we are observing that the piece of metal went up to the surface of the solution, and I see bubbles are being generated in solution, and they are coming out. And if I keep my face over, it's not coronavirus, it's gas which suffocated me for a moment, which is coming as bubbles. I know that it was safe, that's why I did it, but the students should never do that. I am slapping my test tube to speed up my reaction. Oh, the test tube became warm right on the surface where the gas is being generated, the bubbles, and where magnesium is interacting with solution, with HCl, which is in solution. Water, in both cases, in the previous and in this current case, in reaction A and B, is not doing anything. It's just medium. But this medium helps reaction to occur without HCl gas being dissolved in water and without copper sulfate in the previous being dissolved in water, the reaction would not happen. Yes, the test tube is very warm, like the beaker in the previous case. So in terms of energy change, these are two reactions of the same class. And in terms of matter change, these are reactions of the same class. And what now I'm observing, my metal disappeared. We can say it dissolved in solution of hydrochloric acid. But it's not just dissolved. Metal reacted with HCl, which was in solution. And gas, bubbles were produced and went up into the air. And now everything looks like water. But it is not water. It is up to us to determine what are the products of the reaction B. Now we have to take silver chloride. No, we have to take silver nitrate solution in the dark water. I forgot to prepare that in advance. And table salt, which is called sodium chloride solution. I'm going to put small quantity of each solution, and I'm going to move my reactions which are complete out of the picture. And here, two beakers. If we had been running it with students, we would dispense small quantity, it's reaction C, of sodium chloride solution into a beaker, which looks like water, clear, colorless solution, which means it is soluble in water compounds, crystals of table salt. White crystals, when they dissolve in water, if they are soluble, they start looking like water, clear, colorless solution. The same about silver nitrate. It is in a dark bottle for different reasons, but they both look the same, look like water. I'm going to put small quantity of table salt solution in water in a test tube. And small quantity of silver nitrate in the test tube. And now it does not really matter which one I will add to which one. As soon as solution was added, you cannot see through anymore. When these two solutions are mixed together, you cannot see through anymore. It looks, students usually refer to that as milky. You cannot see through, it's not transparent, which means it is not solution. Solutions are transparent. Any soluble in water substance always give us transparent solution. Usually these substances are compounds, and which means originally our reactants were soluble in water solutions, soluble in water compounds. But now we have insoluble in water compounds. Where did it come from? I did not put anything there. It was produced as a product of the reaction between table salt, sodium chloride, and silver nitrate. And it is your job to write down the products of this reaction. And reaction C and the two other reactions which follow, D and E, belong to the class of double replacement reactions. Reactions which take place between compounds. No more elements, and two compounds should be produced. My test tube did not really change in terms of getting hotter or warmer or getting colder or cooler. It stays about the same. So I personally feel no energy change in this reaction, during this reaction. In other words, this reaction is not accompanied by energy change. So, in terms of change in matter, reaction D is going to be the same. I'm trying to move things out of the picture. You see, Bruce, they did not set it up well. It's like showing as if everybody looking from top. It should be, but they're gone. It should be looking more like this showing than from top. But I don't know how to change it, how to fix it. And they will have to re-record it. The second reaction is between two white crystals which are soluble in water and gave us colorless, clear solutions of two soluble in water compounds, barium chloride and sodium sulfate, dissolved in water. Original crystals of these two ionic compounds are white color, but when they dissolved in water, they give us clear, colorless solution. So, we are going to, again, it does not matter which one you add to which one. We are going to pour one solution from one test tube with the solution of another test tube. I'm using significant amount of solution, so it will show in the film. If I had been doing it just in the regular laboratory setting, I would not use that much of the reactants. So again, the same outcome as in the previous case of reaction C. You cannot see through anymore. It is not transparent, which means it is not just solution. There is something suspended in water, insoluble in water, white compound. It will be again your job to write down the product of this double replacement reaction. And I feel no energy change again here. It is very badly set up. You see, it shows as if somebody is looking from the top. Bruce, don't change it. We'll have to re-record it again. Reaction E. Two reactants. Lead nitrate solution, clear colorless solution, which means original ionic compound of white crystals soluble in water, and gave us clear colorless solution. The second reactant is solution of potassium chromate, another ionic compound, yellow crystals soluble in water, and we have yellow solution. And solution means that it is transparent. You can see through. You don't see any more solid, which is soluble in water and dissolve. That's what it means to be in solution. Now, I don't need my original bottles. I can put them away. And what we are going to do, we are going to do the following. We pretend that this colorless solution is just water. And we are going to add yellow solution to this colorless solution. Quite all of a sudden, solution is not colorless anymore. Solution, it's not a solution anymore. I'm sorry, I said not colorless. It's not transparent anymore. It is yellow, and we cannot see through, which means these are yellow crystals. Insoluble in water compound is produced.
Like, yeah, I think a little bit more like that.
No, don't show my face. But Andrew, you see what it is? It is like the view from the top. I want to be the view from the from
Lower
here.
this, yeah, just lower this.
I did not know how I.
a restart, come on.
So I have to redo this. That's okay.
Yeah, we can edit. We don't have to redo it.
Mm-hmm.
Yeah?
Oh, okay, that's, yeah, that's.
Yeah, that's much better. So these are yellow, but Andrew, look, they don't even show as yellow. They show as like too much light.
Yeah, too much light.
Uh-huh.
Maybe I should turn off the.
So this is yellow solid
Showing yellow.
as the two white solids before, suspended in water. So it's not solution anymore. Solution should be transparent, which means we produce insoluble in water compound. And in all three cases, insoluble in water solids, whether they were white solids in C and D, or whether it is yellow solid in E, they're going to settle down. And when they settle down, we refer to this as precipitate. It is a verb, to precipitate, and it is a noun, a precipitate. So we refer to these reactions as a precipitation reactions. C, D, and E are precipitation reactions. It is a subclass of double replacement reactions. You start with the two ionic compounds as reactants, and you produce two new ionic compounds as products. And that's what you have to write in the laboratory manual as the product. Now, there is a unique reaction which is included here. In this class, in this laboratory experiment, which does not fall in any other class studied by us. Actually, it is studied in more advanced courses of chemistry, which has complicated name, which I'm not going to even bring it up to you. Again, two solutions of soluble in water compounds, colorless solution of white crystals, that's why it's colorless. I'm trying to orient myself in terms of the camera. Potassium thiocyanate. It's written as a second reactant in your equation, which means it's white crystal soluble in water. And I put them already in a beaker, and I put the disposable pipe in there. Second reactant, in my case, I'm bringing it as a second reactant, but in the lab manual it's written as a first. Yellow crystals of ferric chloride dissolved in water and given us yellow solution, which you can see through. That's what it means to be soluble in water and giving us solution. I put this also in a beaker with a disposable pipette. So what I'm going to do, in the one experiment, I'm going to demonstrate this twice. I'm going first to put yellow solution into my test tube using disposable pipette. Observe, I'm not inverting my pipette, I'm bringing it like that and squeeze it out. And now I'm going to take colorless solution into my pipette, and now I'm going to lift it so you would see it. And what I'm going to do now, I'm going to take my colorless solution and add drop by drop into my yellow solution. What you can see you can see, probably now I should show it against the white background. Where chemical is added, it got very dark red color. If I slap my test tube, it spreads around, which means I mixed my reactants. And look, it looks like red wine or iodine solution, but it is not, it's something else there. Now I'm going to do the opposite. I'm going to put my colorless solution first. Or was it that I did the same thing? I'm going to repeat it, just in case. This is my colorless solution, goes into a test tube. And I'm adding a couple of drops of the yellow solution in front of the camera. Again, oh, I added too quickly, and you did not even see on top, immediately the whole solution became deep red color. Shows on the white, shows even against the table. So it does not matter whom you are adding to whom. The two reactants react with each other. And there is no solid here. You can see through, but solutions have very intense color. And the second time, I added more chemical, and solution became deeper color. But it's still color change of solution. There is only one change, color change of solution. The same thing, there was only one change in C, D, and E. There was formation of precipitate. On the other hand, if you look back to the reaction A and B, there were several changes. In reaction A, the metal changed color and solution changed color. In reaction B, the metal disappeared and bubbles of gas appeared. And also the heat. But in C, D, and E, there was only one change, formation of precipitate. And in reaction E, there is only one change, color change of solution, and no change which I felt in the temperature. No change, in other words, in energy. Now, reaction G, I have to do over a sink. Oh, I am afraid of moving the camera because I put all the bottles around sink. So let me bring a big test tube. Not test tube, big beaker over which I'm going to do this reaction. This is a very large beaker, and this is baking soda. This is container with baking soda, which is called sodium bicarbonate, chemical name, and common name is baking soda. This is baking soda in a beaker, just certain quantity which I took out from the container. And now I'm going to put some quantity into a test tube. Here it is, my test tube. And I'm going to take the reactant which we used in the previous case in reaction number B, if I can call it a number, solution of hydrofluoric acid. Must be this. Yes. I'm going to put some quantity of this solution into a beaker. And I'm going to take this test tube into my hand and put it into the beaker. I would usually do it over a sink, but the camera, I don't want to move the camera and orient it incorrectly over a sink. So I'm sacrificing my hand in a sense, because you will see something will happen. I am pouring this solution of HCl into a test tube, and look what is happening. Bubbles are coming up, and if I put more solution, more bubbles are coming up. Sometimes the bubbles come if I put more. You see what happens now? If I put more baking soda, the bubbles will start coming out, and together with solution, and they will spill into the sink and into this beaker. I know that my hydrochloric acid solution is not very concentrated, so it's not going to hurt my hand, even if it gets on my hand. So the reaction is happening, and the bubbles, gigantic quantity of bubbles, are coming out of solution. And it will go on as long as baking soda is available at the bottom. But now we see that there is no more baking soda at the bottom, and the bubbles are subsiding, because one reactant is not there anymore. It is a reaction between baking soda and hydrochloric acid, which is in solution. And now just a little bit left over of the bubbles. I am not moving correctly with respect to the screen, not to the screen, to the camera. And these are just leftover bubbles. And now it doesn't matter how much hydrochloric acid solution I will add, it will not show anymore as vigorous bubble production, because we need both reactants to react. The same as when our magnesium disappeared in the test tube in reaction B, doesn't matter how much HCl we would be adding, the bubbles will not be produced because magnesium was gone. Now baking soda is gone. So this is also double replacement reaction, but it is a second or maybe third class of the double replacement reaction, which is called evolution of gas. Bubbles are produced. But here there will be 3 products, and it is your job and your instructor job to write down the product for this reaction. So we had precipitation reactions, C, D, and E, which are double replacement reaction, and reaction G, evolution of gas, another subclass of double replacement reaction. And reaction H is from the same subclass of double replacement reaction as reaction G. It's also evolution of gas. And by the way, what about energy change in this reaction G? My test tube became cooler, not very cold, but definitely cooler than original test tube, which I took by my hand. So surroundings become cooler during this reaction. It is the opposite change in energy than reaction A and B, where surroundings become warm. Now surroundings become cool. So reaction H is another double replacement reaction, where we will have no solution. It is a very rare case when two chemicals, both are solid, two solid compounds, are going to react with each other without need to be dissolved in water. And I'm sorry that I have all this stuff around because I was moving everything towards the screen. Let me move towards the camera. So I never filmed myself, so let me move everything out of the way. I thought the guys will be assisting me, but no, they left me on my own to be an actor and to be producer and operator and whatever. So moving all the bottles, all the containers out of the way. And I don't need the test tubes because I'm going to do this reaction in beakers. These are two beakers where I'm going to put two solid chemicals. The first reactant is a compound, barium hydroxide, white crystals of powder. In chemistry, there is no difference between crystals and powder. Powder are small crystals. That's what all the ionic compounds are. They are all crystals of powder, as we may call them. And I don't want you to think that all crystals are ionic compounds. To say all ionic compounds are solid crystals, it is not the same to say that all crystals are ionic compounds. Sugar is molecular compound, but it's also crystals. So crystals is really a very broad class of compounds. It could be ionic, it could be molecular. Even some elements are crystals. So barium hydroxide, the first reactant, trying to put it into a beaker without putting my spatula into this container. Otherwise, I have run a danger to contaminate my whole container. This is ammonium, NH4, thiocyanate, SCN, ionic compound where instead of metal we have a polyatomic ion, ammonium, which behaves as metals of group 1 when it is in the form of ion. So the first reactant, barium hydroxide, are smaller crystals, very much like baking soda maybe, and the second, ammonium thiocyanate, are bigger crystals, more like sugar, but they are both ionic compounds. Again, it doesn't matter which reactant I add to which reactant. Let me add barium hydroxide to ammonium thiocyanate. And now I have to mix them with a glass rod because the solid compounds are frozen and they don't move like the ones which are dissolved in water. In water, they become mobile. They move together with the water molecules. But here, they don't. So we have to help them to come across each other, to meet each other, so they will react. Oh my God! I put my head over the beaker, and I was hit with a strong smell of the gas, which I didn't even realize would be coming out. Strong smell, like almost the one when they wash the floors. We don't see the bubbles because there is no water in which we have one of the reactants dissolved and the product is bubbling out. The gas came out invisible, but I detected this gas by its smell. It smells of ammonia. That's a hint for one of the products. Now, wow, there was small quantity of water produced. And my white crystals are now swimming in this small quantity of water. Of course, it is not enough water. Like when we make solution, we put a lot of water. Here, a little bit of water is produced, but enough to dissolve a little bit of the crystals. So, since we produced ammonia gas and water, these are two reactants. No, I'm sorry, these are two products. I apologize for me not being so focused on the experiment in terms of I'm paying attention to the camera. And so these are two reactants, ammonia gas and water. But it did not take the account of barium and thiocyanate. So we have to write one more product. And oh my God, the beaker became exceptionally cold. So cold that I could get a frostbite by holding it like that. So reaction G and H belong to the same class of changing matter as double replacement, subclass evolution of gas, and in terms of energy change, everything became cold, which is around chemicals. It is opposite to reaction A and B, when everything became warm around the chemicals. So that would be your job to write down the third product, because I already hinted you about the first two products. And of course, to describe the energy change. Now, we are going to take the same reactant as in the previous one, barium hydroxide. I'm going to put it in a beaker. Again, it is a solid. Small quantity of barium hydroxide, solid white crystals, are put in a beaker. And I'm going to take hydrochloric acid, which we used for the previous case already twice. Now it is the third time. And since I'm doing it in a beaker, I am going to pour from the bottle right into the beaker small quantity of hydrochloric acid. And I'm going to swirl it. Whenever we have solid as a reactant, we want to swirl it, because solid is not moving around. We want to let it move around. And you might say, oh, solid disappeared. Big deal. Solid could disappear in water being dissolved. The beaker became a little bit warm. Not very much, but a little bit, which means it is very much, in terms of energy change, like A and B. Everything around the chemicals become warm or hot. In other words, warmer than it was before. And my solid disappeared. But we should have added to this reaction the following. I should have put an indicator in my original solution of HCl, and then I should see the color change of the indicator after barium hydroxide, the so-called dissolved in water, because it did not just dissolve in water, it reacted. That is another class of double replacement reaction, which we'll study further in the course, which is called acid-base neutralization reaction. That's the only reaction during which, when we go from reactants to products, the indicator will change its color. But we did not include it in the write-up of this reaction. We included only energy change. An observation that the white solid disappeared. But white solid could disappear when there is no chemical reaction, no chemical change, when just lab technicians dissolved all the reactants in water. They made solution of reactants. That was a mixing. There was no reaction when they did it. They prepared compounds dissolved in water. But here, barium hydroxide not only dissolved, it reacted with HCl, which was dissolved in water. So, and it gave us a little bit of energy change, that everything became slightly warmer. And we'll find out later on that HCl is called the acid. Barium hydroxide is called base. And this is acid-base neutralization reaction, which gives away some heat, energy as heat, and your job to write two products. There will be two products. So, that is the end of experimental part, and it is my first time filming in a laboratory. So hopefully we'll improve our filming, and hopefully somebody will help me and assist me during these experiments, if we are going to continue recording them. And maybe it was not very good way we put the chemicals for you to see, because it's still like camera is looking from the top and a little bit too much light and too much reflection. But maybe we will redo this experiment and refilm it, or maybe we'll get satisfied for now, since we have emergency situation in the country and in the world. That's the end of experimental part.